Okay, let's picture a scene for a second. You're in an emergency room, a patient comes in with a really severe infection, and I mean every single minute counts. The doctor has to pick exactly the right antibiotic. It's this incredible balancing act, right? They're weighing the patient's history, what kind of bug it might be, and the huge risk of creating drug-resistant superbugs. It is absolutely one of the most complex, high-stakes decisions in all of modern medicine. And this, of course, is where AI enters the picture. But it raises a massive question. We hear all this buzz about AI, but can we really trust an algorithm in a situation like that? You know, a literal life or death moment? Can it be a reliable co-pilot for doctors, or is the risk just way too high? This is the core challenge we're going to unpack today.
Because here's the thing, you can't just plug any old AI into a hospital and hope for the best. The big general purpose models we read about every day, well, they have some pretty fundamental flaws when it comes to medicine. So let's break down exactly why that is.
And here it is. This is really the heart of the problem. These general AI models, they're trained on these vast oceans of internet data. But get this, less than 0.3% of that data is actual medical content. That's nothing. It means these AIs are often working with outdated medical guidelines, they totally struggle with rare diseases, and they just don't have that deep, specialized knowledge a doctor needs in their bones. This knowledge gap leads to four really critical issues. First, you got that knowledge bias we just talked about. It's just not up to date. Then you have a massive privacy risk. Hospitals can't and shouldn't be sending sensitive patient data up to some external cloud service. Third, the high cost. Training these monster models requires a level of computing power that most hospitals just can't dream of affording. And maybe the most important one of all is what we call reasoning bias. See, these AIs are trained on textbooks, not on the messy, complicated reality of a real patient who has multiple conditions. They can spit back facts, but they can't reason like a clinician. So, with all those pretty serious problems, how do we move forward? It was clear a totally new approach was needed, one that was built from the ground up to solve these very specific challenges. And that new approach is called KRAL. KRAL. It stands for Knowledge and Reasoning Augmented Learning. And that name, it really gets right to the heart of what makes it different. This isn't about being a general, know-it-all AI. It's about creating a specialized, affordable, and most importantly, secure AI that can act as a true decision support tool for doctors, right there inside the hospital.
Okay, so how does it actually work? How does KRAL get so smart, so safe, and so efficient all at the same time? Well, it all comes down to this really unique three-stage training process that is completely different from how those big general AIs are built.
It happens in three key stages. First, something called data distillation. You can think of this as creating a custom private textbook just for the AI. Then comes agentic reinforcement learning, which is basically a fancy way of saying it practices on thousands and thousands of simulated patient cases. And finally, hierarchical evaluation, where a team of both AI and human experts grade its performance to make absolutely sure it's safe and accurate. Let's look a little closer at stage one. A powerful teacher AI securely scans a hospital's own internal treatment guidelines and their de-identified patient records. It then distills all of that unique information into a highly specialized custom knowledge base. And just like that, boom, it solves the knowledge and privacy problems in one single step. The data is up to date, it's totally relevant, and the best part, it never, ever leaves the hospital's firewall. Now for stage two. This is where the real learning happens. Think of it like a game. This student AI practices on thousands of simulated patient cases. Every time it makes a decision that leads to the best clinical outcome, it gets a reward. When it makes a mistake, it doesn't. And over thousands and thousands of these simulated rounds, it starts to learn the complex, multi-step logic of a real doctor. This is exactly how it tackles that huge reasoning bias we talked about earlier. And honestly, this is the perfect analogy for the whole process. It's just like training a new medical resident. First, it hits the books, studying the hospital's specific protocols. Then it goes through an incredibly intense residency, running countless simulations to sharpen its skills. It builds real-world experience, but in a totally safe virtual environment, long before it ever gets anywhere near a real patient. Okay, so the theory sounds fantastic, right? But what about the results? Did it actually work? Well, researchers put KRAL to the test, pitting it head-to-head against older AI methods to see if this new training process really paid off. And the results are, well, they're pretty staggering. Just look at this chart. On the left, you've got the older methods, SFT, getting the right answer on the first try about 54% of the time. Not bad. But on the right, KRAL jumps to nearly 81%. That is a massive 27% leap in performance. In a clinical setting, an improvement that big is an absolute game changer. But what's maybe even more incredible is how it pulled this off. KRAL isn't just smarter, it's radically more efficient. Thanks to some really clever optimization techniques, it needs 100 times less GPU memory to train. And that is the breakthrough that makes this affordable enough for an average hospital, not just some huge research institution with a supercomputer. This table really just sums it all up perfectly. If you compare it to other common AI approaches, like RAG, which is good at retrieving info, or SFT, which is a more standard way to fine-tune an AI, KRAL is the clear winner. It delivers excellent performance on both knowledge and reasoning, it does it at a fraction of the long-term cost, and crucially, it keeps all the data totally secure. It just wins, right across the board. So you see, this is way more than just a clever piece of engineering. The development of KRAL really points to a whole new future for how AI can be safely and effectively brought into healthcare everywhere from major urban hospitals to small rural clinics. So let's just recap why KRAL is such a big deal. It's a complete system that boosts both knowledge and reasoning. Its incredible efficiency means it can actually run on hardware that hospitals can afford. Its on-premise design guarantees data safety. And it's scalable, so when new medical research comes out, the hospital can easily and affordably update its own AI expert. And this really leaves us with a final, powerful question to think about. What does the future of your healthcare look like when every single hospital, from a giant city medical center to the small local clinic down the road, can have its very own AI specialist, trained on the latest local data and available 24/7 to help doctors make the best possible decisions? That's the future a technology like KRAL really makes possible.